So let's take another quick look at slope and point slope form of a line. If you select this link for a slope applet or scan this QR code, it should take you to a website, and scroll down, it kind of looks like this. You can move the points around and slide, and it should show the rise and the run of the line. And at the top it'll have the slope. The rise is 2 and the run is 4, and that's a slope of 1/2. Well, in this graph I'm given a line and I want to find its equation. If I can tell for sure where the y-intercept is, I would want to use that in my equation. Looks like it's -4.5, but I'm not 100% sure. So I am going to find a couple of points that I feel more confident have integer coordinates. Okay, so like this one, and maybe this x-intercept. And finding the slope of the line by counting the rise, which is 3, and the run, which is 2. I then know the slope of the line is 3/2. Well, now I'm going to use the slope and one of the points that I know in point slope form in order to find an equation of the line. So substituting those values and then simplifying, we determine that the y-intercept is in fact -4.5. And my equation of the line is y equals 3/2 x minus 9/2. Well, here is another applet if you are interested to practice graphing lines. In slope-intercept form, a line's equation is given y equals -3x plus 4. I want to locate the y-intercept, which in this case is at 4. And the slope is -3, and so that means the rise is -3 and the run is 1. And then when I've gotten it correct, luckily it tells me, and I can select new line and try again if I would like. So graphing the line y equals -5/3 x plus 4, we can recognize the slope is -5/3 and the y-intercept is 4. So to graph, I'll first locate the y-intercept and then use the rise and the run to determine another point on the line. So the rise is -5, so I'll count down 5 spaces, and the run is +3, so I'll count right 3 spaces, and then connect those 2 points with a line. But we also want to draw a line that is parallel to the given line and passes through the point 0, -1. I'll actually plot the point 0, -1. And in order for me to make a line that's parallel to this given line, it needs to be slanted the same way, so that way they never intersect one another. And so really, I'm just trying to find a line that has a y-intercept of 0, -1, and has the same slope as the first line, which is -5/3. But this time, if I count the rise as -5, 2, 3, 4, 5, I end up off my grid. Instead, I may use a rise of 5 and make the run negative. So I'd count up 5 from the y-intercept and left 3, and then I know that that line should pass through this point. And another example, we want to draw a line perpendicular to the original line, passing through the point -3, -2. So once again, I'll plot the point at -3, -2. And then to help me know where I'm going to draw my new line, I'll just make sure that it is perpendicular using this right angle in this right triangle, and hopefully find a line that looks something like this. Well, we don't always have a graph given, so it would be helpful to know what the slope of the perpendicular line is. Well, the slopes of perpendicular lines, their product is -1. So can you think of a number that we could multiply -5/3 by to get a result of -1? Well, in this case, it's 3/5. But if you just recognize that these two numbers are related in such a way that they're opposites of one another, one's negative and one's positive, and 3/5 is the reciprocal of 5/3. So we can say they're opposite reciprocals. And look at our graph and double check, starting with this point, that this line has a slope of 3/5. Well, we have some special lines, one being a horizontal line, which has equation y equals some constant. So this line, for instance, would have equation y equals 5. And it turns out that this is really in slope-intercept form, y equals mx plus b, because the slope of a horizontal line is just 0. Vertical lines, on the other hand, have equation x equals some constant. So this line would have equation x equals 4. And we say that the slope of a vertical line is undefined, since the run, how far you'd count horizontally, is 0. So we want to write equations of each of the given lines. Number 1, a horizontal line passing through the point 2, 4. Okay, so knowing that horizontal lines have equation y equals some constant, and recognizing what the y coordinate of this point is, would be the same for all of the points on that line. Then our equation is y equals 4. In number 2, we're given a line has a slope of 1/2 and passes through the point -4, 1. Because this point is not the y-intercept, I may use point-slope form to find our equation. And then just simplify, which gives us y minus 1 equals 1/2 times the quantity x plus 4, and distributing on the right to get 1/2 x plus 2, and then adding 1 to both sides. So y equals 1/2 x plus 3 is the slope-intercept form equation of the line described. And lastly, we want to write an equation of a line perpendicular to the given line and passing through the point 0, -1. So we really need the slope of the given line in order to find the slope of the line that's perpendicular to it. So I'm just going to quickly transform this equation to slope-intercept form by adding 2x to both sides and then dividing by 3. And now I can tell easily that the slope of the given line is 2/3. And using the relationship between the slopes of perpendicular lines that we saw earlier, the slope of our new line is the opposite reciprocal, so -3/2. And then lastly, we are given the y-intercept this time. We can write an equation quickly in slope-intercept form as y equals -3/2 x minus 1.